All right, everyone. Allow me to share my screen first. Okay. Hello, everyone. My name is Peter, and I have been writing software for a very long time. Over the past decades, I have mostly worked with the Apple platforms such as iOS and macOS, but I really hope to add Vision OS to that early next year. Today, we are going to learn how you can improve your application development experience using Bazel. First, I'm going to say why you should consider using Bazel in your project. We will build our understanding of the build process, check out some of the big names that are using Bazel today. We will compare Xcode and Bazel side by side, and I will guide you through the setup process, the Bazel-based application for iOS. And see if we have time, I will demonstrate some of the more advanced concepts that are especially beneficial when working with a team. And we will end up with a Q&A session. During this talk, I will be showing some slides to illustrate what I'm saying, but most of the time I will be sharing my screen to demonstrate how things actually work, rather than boring you with the theory. During the talk, please don't hesitate to ask questions if you have any in the chat section below. And with that out of the way, let's begin. Let's begin with a question for everyone. Do you remember your first program? For me, it was this one. I still remember how I copied this exact text from a book, figured out how to run the compiler, and saw this text on screen. Then to make this program more mine, I went back, changed some line, and rerun the whole code again. And of course, the text on the screen changed. This is the most basic visualization of a build process. And fast forward 20-something years, of course, today we all work on something that's many magnitudes more complex than a simple program that prints lines on screen. But what's interesting is that the mechanisms that power all that did not really change. Sure, we now use powerful software that automates and abstracts away the complexities of the build process. But deep down, it's still the same, a command line invocation of a compiler that accepts source files and outputs the binary. And since this talk is focused on building iOS apps, let's jump into Xcode to prove that. I have a project set up here for this purpose. This is a fairly simple project. Not much is going on here. I will change something so that it builds. Hit command build. And you can see that in the build log, there is a list of commands that Xcode issues for to build the app. And this one is actually the one that builds our source code. At first glance, it looks nothing like what builds my Hello World example. But if you look closer, it's actually the same. You can see that this one here is the compiler, and this is our source file. And the rest is what the Xcode needs to build the app properly. So now that we have demystified what happens when you press build, let's proceed to the topic of this talk, which is Bazel. Bazel is a build system designed by Google. First, it started as an in-house project under the name Blaze and was later open sourced. Bazel was specifically engineered to handle Google-like workloads, which means it natively supports projects with millions of lines of code with complex dependency graphs, and where modules are routinely written in all sorts of different languages. And Bazel is actually not the only build system of this kind. Facebook uses their own version of that, which they call Bug, and they are currently writing the second iteration of that. Twitter has built pans for them, and there's also a Please Build. We will not be covering those build systems, but I should mention that they are very similar in their concept. So overall, we can see that all these big tech companies have converged to using a set of very similar tools, which in itself should provide you with the validation to the idea of looking into one yourself. And here is an incomplete list of some of the users of Bazel. So we have Dropbox, Line, LinkedIn, Lyft, Pinterest, Reddit, Snapchat, Spotify, Stripe, Tinder, Twitter, Uber. So basically every major company is using Bazel now. And of course, Google is using Bazel as well, both internally and externally. And if you have ever tried to build TensorFlow from source, you might have noticed that it involves quite a lot of Bazel. And the list goes on. The still incomplete one can be found at bazel.build/community/users. So all these major companies use Bazel. They must know something, right? Let's check out the benefits of Bazel by comparing it to the Xcode way of doing things. We are going to simulate some of the tasks that we have to deal with on a daily basis. I'm going to assume that we use Git to store and synchronize code with our imaginary teammates. In the first scenario, I'm going to open my repository that I'm working on. Here, I'm working on the feature branch 1, and someone else is working on the feature branch 2. I think maybe I'm ready to merge, so I'm trying to do that. And of course, there is a merge conflict, which happens quite a lot with Xcode. And it's in the worst place possible in the Xcode project. This one is not bad, but it might have been a disaster. And you always end up hoping that's not break something when you merge them by hand. So I will roll this back. And I have actually merged before into another branch, which looks like this. Okay, now that we are here, I'm going to open this project and try building it. So you can see it's the same project from before with some code that simulates bigger projects. It will take a while to build, and I press build. You can see that I actually have to wait quite a long time for it to complete, about 20 seconds, because Xcode doesn't have this exact version of the code in cache. Okay, it's done. And now maybe I want to switch to another code branch. Now I go here, check this out, and try to build the app again. So you can see that, again, it needs those 20-something seconds to build the app because it's not in cache right now. And it should end pretty soon. Yeah, it's done. Now maybe I'm not ready to use this branch just yet. So I would like to check out mine again. I can go back and still, even though I've just built the same version, this branch, just 5 minutes ago, it's still taking quite a long time to build because my cache was invalidated by using the other branch. Yeah, this done. But if it were a larger project, then it would be pretty unpleasant to work with. Okay, now let's check out how Bazel handles the same kind of scenario. We open quite similar project with, again, the 2 branches. I'm working on branch 1, and I want to merge branch 2 with exactly the same changes that were in the Xcode example before. You can see that there is no merge conflict because there isn't a project file that could cause 1. This will come in handy before. Later, now I will just go back and demonstrate how well Bazel handles switching between code branches. And now I need to actually generate a project for me, an Xcode project for me, to be able to open it in Xcode. And I will explain how it works later. For now, it just involves this simple command, Bazel run / Xcode project. It takes a couple of seconds and it's done. Now I can open it in Xcode and it looks quite the same. Once again, I can press build and check out what happens in the build log. Now the build log is quite different from what we've seen in the Xcode project before. It contains a lot of strange lines and it's quite unusual. But it can be read with practice. So the build is successful. Now I want to switch to another branch. I go to Git, check out another branch, and create project once again, and build this version of my code. Again, it takes a couple of seconds, but now it's done. And once again, I switch back to first one, generate the project again, and now it should be in my cache. So again, it builds much faster than Xcode. And I can freely go back and forth between different versions of the code. And the build is close to instantaneous every time. This actually demonstrates the first major benefit of using Bazel, deterministic builds and caching. Now let's go back. So traditional build systems like the one used in Xcode, they figure out what needs to be rebuilt by tracking the source file modification times. Build systems like Bazel, they don't care about any such metadata. Instead, the file is actually represented by a hash of its content. And the end result consists of a tree of such hashes, reflecting the shape of the project dependencies. So it's basically a blockchain. That is why I didn't have to rebuild the project, no matter how many times I switched between branches. Once the source code tree is built, it's placed into a persistent cache forever, or at least until you decide to clear the cache. And another benefit of this kind of builds is that you can finally forget the term clean build folder. You have probably been in a situation before where the project is broken, you don't know what's happening, you end up at Stack Overflow in the middle of the night, and the one suggestion that works is to clean your build folder, and after that it works, but you still don't know why. So it does not happen with Bazel at all. Okay, let's move to dependencies. Real projects usually consist of the main part, in-house dependencies, which we usually call modules, and third-party dependencies, which are usually called for libraries. There are several widely used options for handling dependencies in Xcode. CocoaPods and Carthage, which are both getting phased out. SwiftVM, which is now the de facto system for dependencies. There is an option with Xcode subprojects, which is as bad as it sounds. And there's nothing wrong with just dropping a binary framework into your project. We can demonstrate that by going into Xcode project once again. And you can check out that there indeed is a dependency here that is placed as a subproject to the main one. And here we use that. Now, in Bazel, splitting your products into multiple modules is actually the preferred mode of operation. Bazel itself is a bit skewed towards first-party monorepo projects, but with some slight setup, it can be used with any third-party dependency that you want to build yourself. And if everything that you need is just to drop in a pre-built framework, then it's just as easy as with Xcode. And there's also the new option called Bazel Mod, but it's very new, and we will not be covering them today. Okay, let's assume that we have written and tested our code, and now we want to distribute it to our beta testers or the end users. The way to do that is pretty straightforward in Xcode. So we go there. And usually we do that by into the product menu and pressing archive. And now we have to wait for about 35 seconds, as I measured before, because this process involves quite a lot more work from the compiler than the debug builds. For me, it usually takes seconds on this project, which is about 20% more than a debug build, which is understandable. And now it should be ready. Yeah. And now let's imagine that I forgot to change something in one of my dependencies. Here, for example. Now to that, I will just add a new line here and try to archive again. We can see that I still have to wait for 5 seconds, even though I only changed one line, and it wasn't even in my main module. No matter how many times I rebuild things, Xcode still needs to archive everything from scratch. And if I don't want to wait and go back to the previous version and try to archive that, still I have to wait for this exact 35 seconds because Xcode doesn't know, or actually doesn't care, that it had built almost the same only a minute ago. Instead, it rebuilds everything from scratch. Now, once again, let's move to Bazel. And in Bazel, the archive action is quite different. We don't build ours from Xcode as usual. Instead, we use the command line. I will explain it more in the end, but for now, I'll just show you the command for that. It's Bazel build. Opt stands for optimized, and here goes my app name. I have already built this version of the app before, so it finishes very quick. And again, let's suppose that I forgot to change something and I want to do that. So I do the change, I try to archive the app again. And again, it works very fast because this time Bazel knows that I only changed one line in a very tiny module. So it doesn't have to rebuild the whole stuff, especially a piece file, because I didn't touch those. So that shows that Bazel is able to reuse the build cache, not only during development, but also during the release builds. So for example, if you have a build server, CI server, that builds everything that you commit to your main branch, then it's quite possibly that going with Bazel and with cache will cut your build time significantly. Now, let's go back to the slides. So it's always a good idea to include unit tests in your application. And it's also the most boring part of the workflow. So I will not bother you with explaining how it works in Xcode or Bazel. But I will say that once again, with Bazel, you can use the same tools that are available to you in Xcode. But unlike Xcode, Bazel can also cache the test results. So if you structure your code in a certain way, it will also cut the delivery time significantly, because with Bazel, you will be able to not retest the parts of the app that have not changed. Okay, let's make a quick overview. First, I demonstrated that there is not much difference in writing code between Xcode and Bazel projects. You can use the same best-in-class editor and debugger that Xcode provides, and with access to the same functions, including the instruments for debugging. Second, we have seen that dependencies work pretty much the same, with a slight variation in how you set them up. And third, I showed you how the archive actually works when using Bazel. Notably, we have seen that when performing normal development tasks like merging branches or making small changes to your app, every time when you rebuild things with Bazel, it's always much faster than with Xcode because of its great cache support. Now, up until now, everything that we have seen was equally possible with both Xcode and Bazel. Now we are going to look into things that Xcode is not able to do at all. And my favorite one is the shared cache support. So with Bazel, you are, of course, able to cache your build projects on your disk. But you can also set up a server for doing that over the network. And all the big tech companies that I know are using this property of Bazel in their workflow. So on this diagram, you can see that's a typical setup for such company. There are many developers and CI servers that connect to the same central server that hosts the cache. With that setup, the developers can reuse the parts of the project that were built by other developers. And there's even more. With the same setup, Bazel can not only use remote cache, but also you can use the remote execution. So the builds themselves can happen on another computer or in the cloud. Again, all these big tech companies make use of that because without that, it would be pretty much impossible to do any work there because their projects and their scale is much larger than what a single computer can handle. You may not be ready to invest in a build server just yet. So you can try that with a cloud solution. One of them is BuildBuddy. They have awesome documentation and are very easy to work with if you want to give them a try. Once you set up everything on your site, using remote builds is as simple as adding a parameter to the Bazel invocation. Okay. Now that we have seen all the great features that you can access by using Bazel in your project, I will finally show you how to set up one yourself. The setup is fairly straightforward, but some things may not be obvious, especially if you are coming from an Xcode-only background. So I will start from the top. You can download Bazel on GitHub. It's github/bazelbuild/bazel. And here on the right, you can usually safely take the latest release. Here in the section, you need to choose the one that suits your OS. For me, it'd be this one because I'm running Apple Silicon. And you just download this file and place it somewhere in your path. Now I have already done that, so let's verify that it works. Indeed it does. And now let's create the project. I will create an empty folder for the project. And now we are ready to set up the project. I will copy these two files from the one that I've already set up before, and I will explain what I mean. So the workspace is basically the root of your project. It contains the description of all the tools that your project uses. The exact contents is not important right now, but you just need to know that this one is pretty standard way of doing things. And the build file is actually what replaces the Xcode project file in Xcode. Here you can see that it contains a bunch of what looks like Python functions, and the one that we care of is this one. This function acts like an entry point to our application, and yes, it does look like Python, and in some way it is. You can actually perform some computation in this file, but it's not recommended to do that. Okay, and what's left to do is we just need to copy our source files. So I will copy these 4 items. This is just a standard info file. This is where our source main app source code lives. The one that we have seen before. This is where our example module is located. Again, the one that we've used before. And we have a resource folder for our storyboard and the app icon. Now that is done, we may want to actually work with this project in Xcode, and there is no Xcode project around. So luckily, Bazel can generate one for us. So to do that, we navigate to this folder in our terminal. Here it is. And we run the following command. Bazel run / Xcode project. Now we are doing this for the first time in this app, so it can take a couple of seconds and should be done. Yes. Now we can see that we finally can open this project in Xcode. So this is our project here. You can see that it's fairly similar to what you would get from Xcode, but with some additional files on the left. So here you have the main code. Here you have your module, and there's even a certificate set up for us. And as usual, we can press build and see it work. Yeah, it's done. And once again, let's see. Let's assume that we have done working on this app and we want to install it on our devices or send for a better testing. To do that, we go to the app folder and we execute this command again. Bazel build, optimized, and our app name. It does that as well. and so we can verify that indeed there is our archive here. Wait. Now this is what you can do with Bazel in terms of working with the project and generating the archive. And I promised to walk you through some of the advanced setup. And let's try to set up our remote cache server. Bazel actually has an open API for this kind of work. So there exist many open and closed implementations for this functionality. The one that I use myself, you can upload from git /batch/jar/Bazel remote. What you will do is just clone this project or disk, go there, the terminal is here, and you would run following command. What's interesting is that this program, the cache server, is actually built in the Go language. But for me, it doesn't matter. I use the same commands for Bazel to build it. In this case, actually, to run the code. I execute Bazel run Bazel remote, which is the name of this program. And then I can pass arguments to it. So I want my cache to store around 30 gigabytes of files. And I want it to store at my home folder / say Bazel cache. Now I have built this project before, so it starts immediately. If you check out this for the first time, you will have to wait for a couple of minutes for it to fetch everything and but now in this log, you can see that it's all up and running, and that the server now accepts gRPC requests on this port. So to make use of this server, I go back to my Bazel-based application. I will just clean the build folder so that it's empty. And to use my remote cache, I just need to pass it as an argument to the Bazel build command. So it will be remote cache equals gRPC localhost, and the port that was mentioned in the log. You can see that it's being built and it's done. And from this log, you can see that it works. And to actually confirm that it works, I will restart the server. I will clean my build folder once again, and I will restart my build. You can see that after a couple of seconds, it's already done. And you can verify that it took all its results from cache instead of building everything from scratch. Here it is. So that's remote cache. It's very useful, especially if you work or if you have a CI server that you would like to make faster. Now we are a bit low on time, so let's proceed to this feature of Bazel. Bazel is a very extensible system Bazel itself doesn't have any support for Swift or Go or Xcode. Everything that's we used today is actually built by the community and is provided for us in the form of plugins. And there are all sort of plugins, pretty much whatever you want to do. You can support any language. You can use other tool chains, even though it's less useful with iOS. And for the first time, you can use Rust. Actually, it's part of your build process, which is way harder to do if you are limited by Xcode. And Bazel itself is, of course, a cross-platform product. It works for Apple platforms, iOS, macOS, watchOS. It, of course, works with Windows, and it works with Linux. So if you would like, you can go the Facebook way or Google way, and you can actually have a large monorepo that contains all your apps in one place, and you can have them all described by the same build system, and you can reuse a lot of the descriptions for the build between platforms, though it's less used in the real apps other than at Google or Facebook. And that's it. Let's remember what we have learned today. So we started with demystifying the build process. I showed you that there is nothing magical about building apps. In the end, it just invocation of some compiler commands on some source files, and everything else is built on top of that. Then we have seen how usual tasks that we do as developers, how we can perform them in Xcode and Bazel, and how Bazel is different in some ways from Xcode. And we've seen that Bazel has allowed for some significant performance improvements during these tasks, mainly because of its great cache support. We have tried to build a project with Bazel from scratch, and I believe I've shown that it's an easy and pain-free process. And we even were able to set up a remote cache server for our project. You can access some additional information on Bazel at bazel.build and on their official GitHub. The Bazel community is generally very great to work with, and there's a very high chance that someone will reply to your issue if you post one. And now that it's done, it's time for Q&A if anyone has any questions. Or maybe I have explained everything that's so good that there are no questions. All right, let's wrap this up, and I hope that someone will get convinced after listening to this talk. And thank you for joining me today. Thank you.